We are going to start now the next lecture, lecture 2 of chapter 13, class 10th mathematics, volume and surface areas of solids. So in the first part we will talk about the conversion of solids from one shape to another and mixed problems. Now the first question we have, it is the dimensions of a metallic cuboid are, these are the dimensions given to us, it is 100 centimeter into 80 centimeter into 64 centimeter. It is melted and recasted into a cube. We have to find the surface area of the cube. So what will be same over here? We are saying it is melted and recasted into a cube. So it means the volume will be same for both these figures. So if we suppose that the side of the cube it is A, then the volume of this cube will be A cube, and that should be equal to the volume of this cuboid, and the volume of cuboid it is 100 into 80 into 64, and on solving this the answer we will get for A, that is equal to cube root of this value. So we can write it is 1000 into 8 cube, so that this is the cube root of this value. So the answer we will get it is 10 into 8, that is equal to 80 centimeter. So this is the length of the side of the cube. So what we have to calculate now, it is the surface area of the cube. So formula for the surface area of the cube we have, it is 6a square. So the answer we get it is 6 into 80 into 80, that is equal to 38400 centimeter square. So this is the surface area of the cube. The next question we have is, how many spherical solid bullets can be made out of a solid cube of lead whose edges measure 44 centimeter. So we are given a cube and we have to transform it into the spherical solid bullets, and we have to see how many such bullets can be formed. So suppose we are saying we can form n such bullets, so, and the radius of each bullet it is given to be 2 centimeters. The radius for each bullet that is given to be 2 centimeter. So the volume of the n bullets and the volume of this solid cube of lead, it should be same. So the volume of the cube we have, it is 44 into 44 into 44, and that should be equal to the volume of the n bullets. We are saying suppose there are n bullets and the volume of these bullets will be 4 by 3 pi. The value of r we have, it is 2 cube. So on solving this we will get the value of n, that is equal to 44 into 44 into 44 into 3 into 7 upon 4 into 4 into 2 into 22. So these two gets cancelled, it is 44 over here, these get cancelled, it is 11 over here, and this is 11 over here, and on multiplying these values we will get the answer is 2541. So the number of bullets we have, it is 2541. Next is, how many silver coins 1.75 centimeter in diameter and thickness 2 mm must be melted to form a cuboid of dimensions this. These are the dimensions of the cuboid that are given. So if we change this 2 mm into centimeters, we will get it is 0.2 centimeter. So suppose the number of coins we have, it is n coins. So the volume of this cuboid we have, it is 5.5 into 10 into 3.5, and that should be equal to the number of coins into the volume of each coin. So coin is in the shape of the cylinder. We are saying the coin we have, it is of the shape of the cylinder, and the thickness is given to be, thickness over here means it is height, it is 0.2 centimeter, and the radius given over here, the diameter over here, it is 1.75 centimeter. So the radius we obtain, it is 1.75 by 2, that is equal to 7 by 8 centimeters. So the volume of each coin, that will be pi, that is 22 by 7 into radius we have it is, so it is r square. The value of r we have it is 7 by 8, so it is 7 by 8 into 7 by 8 into h, and the value of h we have it is 1 by 5. So when we calculate the value of n, we will get it is 5.5 into 10 into 3.5 divided by the terms we have over here, it is 22 into 7 into 7, and over here we have 7 into 8 into 8 into 5. So if we remove this decimal, this 10 will be cancelled, and when we remove this decimal we have 10 over here. These two 7, these two gets cancelled. We get by dividing with 11 we are left with 2 over here, and this 7 5s are 35, and this 5 and 10 gets cancelled, and over here we are left with the value that is equal to 2. So the answer we get over here, that is equal to 10 into 40, that is equal to 400. So we are saying the number of coins that are required, that is 400. Next is a metallic sphere of radius 10 centimeter is melted. It is a sphere of radius 10 centimeter is melted and then recasted into smaller cones, and it is recasted into cones, each of radius 3.5 centimeter and height 3 centimeter. How many such cones can be formed? So suppose we are saying there are n cones. So the volume of the sphere we have, the formula is 4 by 3 pi into r cube, means 10.5 cube, and we are saying how many smaller cones are to be formed. Say it is n cones are to be formed, and the volume of each cone that we will have it is 1 by 3 pi. The value of radius we have it is 3.5 square into the height we have it is 3. So the value of this 1 by 3 and 1 by 3 gets cancelled, this pi and pi gets cancelled. So the value of n we get it is 4 into 105 into 105 into 105 upon 35 into 35 into 3, and on solving this value, the answer we will obtain, it is equal to these two values, 35 and this gets cancelled, we are left with 3, 35 and this gets cancelled, we are left with 3, and these two values, these gets cancelled. So the answer we are left with is into 10 over here when we remove this decimal from 105. So if we divide these values with 5, we are left with 2 over here, and it is 21, and these two values gets cancelled and we are left with 2. So the answer we are left with is 21 into 6, that is equal to 1 to 6. So we are saying the number of cones, the required number of cones, that is equal to 126. Now the next question we have is the internal and external radii of a hollow sphere are 3 centimeter and 5 centimeter respectively. So a hollow sphere is given, and it is given that the internal and external radii that we have over here, it is 3 centimeter and 5 centimeter. The sphere is melted to form a solid cylinder. A solid cylinder is formed whose height is 2 whole 2 by 3 centimeter. Find the diameter and the curved surface area of the cylinder. Suppose the radius of this cylinder, it is r. So first of all we are calculating the volume, because it is given that the sphere is melted and recasted in this form. It means volume of the material will be same. So the volume of this hollow sphere, that will be 4 by 3 pi into 5 cube minus 3 cube. This is the volume of the hollow sphere, and this should be equal to the volume of this cylinder, and the volume of this cylinder, it is pi r square. The radius, it is r square, and the height we have it is 2 whole 2 by 3, and this 2 whole 2 by 3 means it is equal to 8 by 3. So both these values should be equal. So this pi gets cancelled, 4 gets cancelled over here, this 3 gets cancelled over here. So we are left with this 5 cube minus 3 cube divided by 2, that is equal to r square. On solving these values, we will get 5 cube, that is equal to 125, minus 27 over 2, that is equal to r square. So the value of r square we have, it is equal to 98 by 2, that is equal to 49. So the value of r we have, that is equal to 7 centimeters. The next thing we have to calculate is the diameter. So the diameter we will have, it is double of the radius, so that will be equal to 14 centimeter. And curved surface area of the cylinder, the formula for the curved surface area of the cylinder, it is 2 pi rh, and the value we get, it is 2 into 22 by 7 into 7 into 8 by 3. On solving this, the answer we will get, this 7 and 7 gets cancelled, and on multiplying these values, we will get 352 by 3, that is equal to 117 whole 1 by 3 centimeter square. So this is the curved surface area of the cylinder. The next question we have is, a hollow sphere of internal and external diameter 4 centimeter and 8 centimeter is melted to form a cone. These are the internal and external diameter. So internal radius, that will be 2 centimeter and external radius will be 4 centimeter. It is melted to form a cone whose base diameter is 8 centimeter. So radius we have, it is 4 centimeter. We have to find the height and the slant height of the cone. So it is melted, it means the volume will be same. So the volume of this spherical shell we are talking about, hollow sphere we are saying, its volume will be 4 by 3 pi into 4 cube minus 2 cube, and this value should be equal to the volume of the cone. Suppose the height of the cone we are saying it is h, and the slant height we are saying it is L. The radius we have, it is 4. So the formula for the volume of cone, it is 1 by 3 pi into r square, means 4 square into h. So this pi gets cancelled, this 3 gets cancelled, and this 4 gets cancelled over here. So the value of h we have, that is equal to 64 minus 8 upon 4, and the answer comes out to be 14 centimeters. Now the next thing we have to calculate, it is the slant height. So we are talking about a cone over there, a cone is there. We are saying the height of this cone, this is 14 centimeter. The radius of this cone, it is given to be 4 centimeter. We have to calculate the slant height. So the slant height L, that is equal to square root of 14 square plus 4 square, that is equal to square root of 212, and that is equal to 2 root 53 centimeters. So this is the slant height of this cone. Next is, a girl empties a cylindrical bucket full of sand of base radius. So a cylindrical bucket is there, and the base radius of this cylinder, it is 18 centimeter, and height we have, it is 32 centimeter, on the floor to form a conical heap of the sand. We are saying they have emptied this bucket and a conical heap is formed. If the height of this conical heap is 24 centimeter, the height we have, it is 24 centimeter, then find the slant height correct to 1 decimal place. Suppose we are saying the radius it has r and the slant height it has L. So the volume of this cylinder, that is equal to pi r square, pi into r square, means it is 18 square, into h, it is equal to 32, and the volume of this cone we will have, it is 1 by 3 pi. The value of radius is not known to us, so it is r square into height we have, it is equal to 24. So this pi gets cancelled, and the value of r square we will have, it is 18 square into 32 into 3 upon 24. Now on solving this value, we will get the value of r, that is equal to 18 into 2, that is equal to 36 centimeter. So radius we obtain, it is equal to 36 centimeter. Now the next thing we have to calculate, it is the slant height L. So the slant height L, that is equal to square root of 36 square plus 24 square, that is equal to square root of 1296 plus 576, and that is equal to square root of 1872. And when we calculate the square root of 1872, we are talking about this thing, that we have to calculate the square root of this value. So we are saying 4 4s are 16. The remainder we are left with is 2. So we get 272. So we have 8 over here. So we are saying 43. We get 43 over here. So we are multiplying 83 with 3. And the answer we will obtain, that will be equal to 249. So we write 249 over here. And the remainder that is left over here, it is 23. Now we put decimal over here, we obtain 2 zeros over here. So the next term we will have, that will be equal to, the next term we will obtain over here, that will be 86. And when we continue in this way, the final answer that we will obtain, it is 43 point, the square root of this value we will obtain 43.26 centimeter. The answer we have to write, it is up to 1 decimal place. So by rounding this term, we will get the answer is 43.3 centimeter. This is the required slant height up to 1 decimal place. Now the next question, we have 504 cones, each of diameter 3.5 centimeter and height 3 centimeter are melted and recasted into a metallic sphere. So we have to find the diameter of the sphere. Suppose the radius, we are saying the radius of the sphere, it is r, and hence we have to find its surface area. So the volume of this sphere, the formula we will have, it is 4 by 3 pi r cube, that is equal to, we have total 504 cones and volume of each cone, that will be equal to 1 by 3 pi. The radius is 35 by 20. This is 3.5 by 2 centimeter. This is the radius, and the height we have, it is 3 centimeters. So this 3 and 3 gets cancelled, pi and pi gets cancelled. So the value of r that we obtain, we are saying r cube, that is equal to 504 into 35 into 35 into 3 divided by 20 into 20 into 4. So when we divide these values, we get it is 7 over here, 4 over here, you get 7 over here and 4 over here. Now if we look at this term 504, so 504 we can write it is 72 into 7. So what we get is that the value of r that we have, it is 7 by 4 common. We are taking the cube root on both sides. So there are 3 7 over here. So we are writing 7 by 4. There are 3 4 over here. And we are left with this cube root of 72 into 3. The answer we will obtain, it is 7 by 4 into this 72, we can write it is 9 into 8 into 3, and it is cube root of this term. So the answer we get, it is 7 by 4 into 3 into 2. These two values get cancelled, and the answer we are left with is 21 by 2 centimeters. So we have to find the diameter of the sphere. So the diameter will be 21 centimeters. The next thing we have to calculate is the surface area of this sphere. So the formula for surface area, we are saying the formula for surface area, that is equal to 4 pi r square. The value of r we have, it is 21 by 2 square. So we get it is 4 into 21 by 7 into 21 by 2 into 21 by 2. On multiplying, it is 22 by 7 into 21 by 2 into 21 by 2. On multiplying all these terms, the answer we will obtain, it is 1386 centimeter square. So this is the surface area of the sphere, and this is the value of the diameter of the sphere. Now the next question we have is two spheres of same metal weight 1 kg and 7 kg. The radius of the smaller sphere is 3 centimeters. Suppose this value we are saying it is R1, and the two spheres are melted to form a single big sphere. Find the diameter of the new sphere. We have to calculate the diameter of the new sphere. Suppose the radius of this new sphere, it is capital R. Now it is given that the ratio of their weights, the ratio of the weight of first sphere to second sphere, it is 1:7, and we know that the weight is directly proportional to volume. It means the volume of first sphere, the ratio of volume of first sphere to second sphere, it is 1/7. So if we write the formula for both of these, the answer we will get, it is 4/3 pi R1 cube over 4/3 pi R2 cube. So this 4/3 gets cancelled, and the value of R1, this value of R1, it is given to be 3 centimeters. So with the value of R2 cube, we will get it is 3 cube into 7, and that is equal to 189. This is the value of R2 cube. Now both the spheres, they are melted, and they are, when the new sphere is formed, a single big sphere is formed. So the sum of their volumes, we are saying, the sum of their volume means V1 plus V2. This is equal to the volume of the new larger sphere. So if we write the formula for both these, we are saying it is 4/3 pi R1 cube plus 4/3 pi R2 cube, that is equal to 4/3 pi capital R cube. So this 4/3 pi, 4/3 pi and 4/3 pi gets cancelled. The value of R1 cube we have, it is 3 cube. The value of R2 cube we have, it is 189, and this value is equal to capital R cube. So this value is equal to 27. On adding both these values, 189 plus 27, the answer we will get, that is equal to 216. So we are saying R cube is equal to 216. So the value of R we will get, that is equal to 6 centimeter. And what we have to calculate, we have to find the diameter of the new sphere. So the diameter we are saying, that is equal to 2 times 6, that is equal to 12 centimeters. This is the diameter of the new sphere. Now the next, it is given that the diameter of a copper sphere, it is 6 centimeters. So the radius of this sphere, that is equal to 3 centimeters, and the sphere is melted and drawn into a long wire with uniform cross section. Long wire with uniform cross section means that the wire is melted and it is in the form of, now it is in the form of a cylinder. Uniform cross section means that this, if we cut the wire at any point, the radius over here, that is, say it is equal to R, it is same at all these points. If the length of this wire, it is 36 meter. So 36 meter means, when we convert it to centimeter, it is 3600 centimeter. This is the length of this wire. Find its thickness. So if we write the volume of the sphere of radius 3 centimeter, the formula we have, it is 4/3 into pi into R cube, and if the radius of this cylindrical wire, it is R, and the length is 3600 centimeter, then the volume we have, it is pi into R square into height, it is 3600. So this pi gets cancelled, and the value, this 3 gets cancelled over here. So we get, it is 4 into 9 by 3600, that is equal to R square. So the value, this is the value of R square. So the value of R that we will get, that is equal to 1/10 centimeter, and this is equal to 1 mm. So what we have to calculate, we have to calculate the thickness of this wire. So thickness of the wire means we have to calculate the diameter, and the value of diameter, that is equal to 2 mm. This will give us the thickness of this wire. Now the next we have is find the number of coins 1.5 centimeter in diameter and 2 mm thick. So the diameter of the coin, it is given 1.5 centimeter. It means the radius of this coin, that is equal to 1.5 by 2 centimeter, and 2 mm thick means this is just like the height it is given to us, and the value of height is 2 by 10, that is equal to 1 by 5 centimeter, and it is to be melted to form a right circular cylinder of height 10 centimeter and diameter. If diameter is this, it means the value of radius we have, it is 4.5 by 2 centimeter. So we are saying these coins are to be melted and we have to form the cylinder. So the volume, the number of coins, it is n, so the volume of these n coins, that should be equal to the volume of the cylinder. So the volume of the n coins, that is equal to n into pi r square h. This is the height of these coins. That should be equal to pi capital R square h. Pi and pi gets cancelled. We will get the value of n, that is equal to r square means it is 4.5 by 2 square. The value of height we have, it is 10, divided by, it is 1.5 by 2 square, and the height we have, it is 1 by 5. So the value of n that we will obtain from here, it is, we are saying n is equal to 4.5 by 2 into 4.5 by 2 into 10 into 5 into 2 into 2 over 1.5 into 1.5. And on solving this, we will get these 2 gets cancelled, 1.5 get cancelled over here, this 1.5 get cancelled over here. So we are left with the answer, that is 450. So we are saying that required number of coins, it is equal to 450. Now the next we have is a solid iron rectangular block of dimension 4 meter, 2.6 meter and 1 meter is cast into a hollow cylindrical pipe of internal radius 30 centimeter. We are talking about a hollow cylindrical pipe is there, and the internal radius of this pipe, it is given to be, this internal radius over here, it is given to be 30 centimeter, and the thickness of this pipe, it is given to be 5 centimeter. So the external radius we have, that is equal to 35 centimeter. Suppose the length of this pipe, it is h. So the volume of the rectangular block and the volume of this hollow pipe, this should be same. So the volume of the rectangular block, these values, these are given in meter. So if we convert them in centimeter, we multiply these values with 100. So the answer we obtain, it is 440 into 260 into 100, that is equal to the volume of this hollow pipe, and the volume of this hollow pipe, it is pi into h into 35 square minus 30 square. So the value of h that we will obtain, that is equal to 440 into 260 into 100 into 7 upon 22 into, when we solve this value over here, we get it is 35 minus 30 into 35 plus 30, and these values comes out to be 5 into 65. So on solving these values, yes, suppose divide these two numbers, we are getting it is equal to 20 over here. So we get it is 5 4s are 20. Then we are cancelling these values, it is 13 5s are 65, and it is again 20 over here, and it is 5 4s are 20, and the final answer that we will obtain, it is equal to 112 into 100 centimeter, and this is equal to 112 meter. So this is the length of the pipe. Now the next question we have is, a hemispherical bowl of internal radius 9 centimeter is full of liquid. So we are talking about a hemispherical bowl, and the internal radius is given to be 9 centimeter. The liquid is to be filled into a cylindrical shaped small bottles there are cylindrical shaped small bottles and liquid is to be transferred in these bottles. Suppose there are n such bottles, each of diameter 3 centimeter. The radius of each of these, it is 3 by 2 centimeter, and height of each of this bottle, it is equal to 4 centimeter. So how many such bottles are required? Suppose we are saying there are n bottles. So the volume of the fluid in this hemisphere, it is 2 by 3 pi into r cube. This is the internal radius, and this should be equal to the number of bottles we have, it is equal to n, and the volume of each bottle, it is equal to pi r square into height is 4. So this pi gets cancelled, and what we get is that the value of n we have, it is 2 into 9 into 9 into 9 into 2 into 2 over 3 into 3 into 3 into 4. So these two values get cancelled, these 3 gets cancelled over here, and we are left with 54. So the value of n, that is equal to 54, that is the required number of bottles, is equal to 54. Now the next we have is a hemispherical bowl of internal diameter 36 centimeter contains liquid. So the radius of this bowl, it is 18 centimeter. This liquid is filled into 72 cylindrical bottles of diameter 6 centimeter. So radius of these cylindrical bottles, it is 3 centimeter. Find the height of each bottle if 10% of the liquid is wasted in this transfer. So the total amount of liquid in the hemispherical bowl, that will be 2 by 3 pi r cube. The value of r we have 18 over here, and it is given that the 10% of the liquid, it is wasted. So how much liquid is left? It is 90%. So we are saying 90% of this value, this is the amount of fluid that is to be transferred to the cylindrical bottles. Now the number of cylindrical bottles we have, it is 72, and volume of each cylindrical bottle, that will be equal to pi capital R square capital H. Capital H is the height, and capital R, we are saying this is the radius over here. So this pi and pi gets cancelled. So what we are left with is that 2 by 3, it is 2 by 3 into r cube. The value of r cube, it is 18 cube into 90 by 100, that is equal to 72 into the value we have, it is 3 square into h. So the value of h we have, it is 2 into 18 into 18 into 18 into 90 upon 3 into 100 into 72 into 3 into 3. So this 3 3s are 9, these two gets cancelled, we get 10 over here, and these two values get cancelled. Then we have 3 6 is a 18. So on solving this, we get, it is 18 4 is a 72. So it is 2 and 3. So the final answer we are left with is 54 by 10, that is equal to 5.4 centimeter. So this is the height of each bottle. In this next question, it is given that a conical vessel whose internal radius is 5 centimeter. So the vessel is in this form, and the internal radius over here, it is 5 centimeter, and the height is given to be 24 centimeter, is full of water, and the water is emptied into a cylindrical vessel with internal radius. The internal radius of this cylindrical vessel, this is 10 centimeter. Find the height to which the water rises in the cylindrical vessel. So the amount of water over here, this water, it is transferred to this cylinder, and suppose it is filled up to this point over here. This cylinder, it is filled up to this point. So we have to calculate the height up to which this cylinder is filled. So the height of the, we have to calculate over here. Suppose it is capital H. So the volume of the water over here and volume of water in this cylindrical vessel, they are same. Volume in this vessel, it is 1 by 3 pi r square into H. The value of H we have, this is 24, and this should be equal to the volume of water in this cylindrical vessel, and it is pi r square capital H. So the value of capital H we have, this pi gets cancelled, so it is 25 into 24 over 3 into 100. These two gets cancelled, it is left 4. So the answer you will get, it is 2 centimeters. So this is the height of the water in this cylindrical vessel. Now the next question we have is, a sphere of diameter 6 centimeter is dropped. So the radius we have, it is 3 centimeter. Suppose we are writing it with capital R. Is dropped into a right circular cylindrical vessel partly filled with water. So a cylindrical vessel is there, and this is, suppose it is partly filled with water. It has water up to say this level, and a sphere is dropped into it, and the radius of this sphere, it is 3 centimeter. So the level of the water will rise. Say the level of water rises up to this point. The diameter of the cylindrical vessel is 12 centimeter. In the radius over here, this is equal to 6 centimeter. If the sphere is completely submerged in water, by how much will the level of the water rise in the cylindrical vessel? So we are saying we have to calculate this height, that by how much amount this water level will increase. So the water level will increase, this volume of the water, this will be equal to the volume of this sphere. The volume of this portion of water, that will be equal to volume of this sphere. So the formula for the volume of this sphere, it is 4 by 3 pi, radius of the sphere, it is 3 cube, and this should be equal to volume of this much amount of water, that is equal to pi, radius of this cylinder, it is r square, and suppose this height is equal to capital, or it is H. We are saying this height, the increase in height of the water, it is H, so it is H over here. So this pi and pi gets cancelled, so the value of H we get, it is 4 by 3 into 3 into 3 into 3 over 6 into 6. So these values gets cancelled, and the value of H we get, that is equal to 1 centimeter. So we are saying the rise in the level of water, that will be equal to 1 centimeter. Now the next question we have is, Sushant has a vessel in the form of an inverted cone open at the top. So we are talking about a vessel is there, and this vessel is open at the top, of height 11 centimeter. The height of this vessel, it is given to be 11 centimeter, and the radius of the top is 2.5 centimeter, and is full of water, and this vessel, it is full of water. Metallic spherical balls, each of diameter 0.5 centimeter, it means the radius of these balls that we will have, it is 0.5 by 2, that is equal to 0.25 centimeters. This is the radius of these balls. They are put into the vessel, due to which 2/5 of the water in the vessel flows out. It means if the volume of the water in this vessel, it is VC, then 2/5 of it flows out. It means this much volume of water, it comes out of this vessel when we drop these balls into the vessel, into this conical vessel. How many balls were put in the vessel? So suppose we are saying n such balls, they were dropped. So we are saying the volume of n such balls, it is n into 4 by 3 pi into r cube is 0.25 cube, and this value should be equal to the 2 by 5, that is the volume of the water that comes out of this vessel. So it is 2 by 5 times volume of this cone, and volume of this cone, it is 1 by 3 pi r square. Radius over here, it is 2.5 square, and the height we have, it is equal to 11. So this pi and pi gets cancelled, this 3 and 3 gets cancelled. We want to calculate the value of n. So the value of n we have, it is 2 by 5 into 2.5 into 2.5 into 11 divided by 0.25 into 0.25 into 0.25 into 4. So when we simplify these terms, we will get, so on simplifying these terms, these two terms, when these are cancelled, we are left with 10 over here. When we simplify these two, we get 10 over here, and if we remove decimal from here, we will get 100 over here. Now we have, this is 25 into 4, this is equal to 100, so these two gets cancelled, and now multiplying all these values, we will get, this is 2200 upon 5, and answer comes out to be 440. So we are saying the number of balls required, the value of n we have, that is equal to 440. Next is, a vessel full of water is in the form of an inverted cone of height 8 centimeter. The height of this vessel is given to be 8 centimeter, and the radius of its top when it is open is 5 centimeter. This is the radius of the top. 100 spherical lead balls are dropped. We are saying there are lead balls are dropped. How many lead balls are there? 100 such balls are there which are dropped in this vessel, and 1/4 of the water flows out of the vessel. So if suppose the volume of the water in the vessel, it is Vc, then 1/4 of this water it comes out. The water that flows out, it is 1/4 times volume of this vessel. So we have to calculate the radius of these spherical shells. So the radius, suppose we are saying it is equal to capital R. So the volume of this conical vessel is 1/3 pi. The radius over here, it is 5 into 5 into 8, and this should be equal to, how many balls are there? There are 100 balls are there, and the value of the volume of each ball, it is 4/3 into pi into r cube. R is the radius of this. There are total 100 balls, so we are multiplying it with 100. So this pi gets cancelled, this 3 gets cancelled, so we are left with this r cube is equal to 5 into 5 into 8 divided by 4 into 4 into 100. So this 4 2 is 8, 2 2 is 4, and we are left with this 25, and this get cancelled, we are left with 4. So the answer we are getting, it is 1/8. So the value of r that we will get, it is 1/2, that is equal to 0.5 centimeters. So we are saying that the radius of a spherical ball is 0.5 centimeters. Now the next question we have is, a housing society used to collect rainwater from the roof of its building. It is 22 meter into 20 meter to a cylindrical vessel. It is collected to a cylindrical vessel having the diameter base 2 meter and height 3.5 meter. So we are saying the roof of the building is there. This is the roof of the building, and the dimensions is 22 meter into 20 meter. The water is collected on this building, and then it is transferred to a cylindrical vessel, and the dimension of cylindrical vessel, the base radius, it is 1 meter, and the height we have, it is 3.5 meter, and then pump this water into the main tank so that all members can use it. On a particular day, the rainwater collected from the roof just filled the cylindrical vessel. Find the rainfall in centimeters. So we are saying, suppose this vessel is completely filled, It means the volume of the rain, that is equal to the volume of this cylinder. The amount of water we have, it is equal to the volume of this cylinder, and that rain actually fall over here on this roof. So if we say that the height of this rain over here, it is h. Suppose this is the plain roof we are talking about. When the water falls on it, it will start collecting over here, and it is collected up to some height, and we are saying that height we have, that is equal to h, and we have to calculate the value of this h. So it means the volume of the rain that we will have, that will be equal to 22 into 20. Say the height, it is h, and that should be equal to the volume of the cylinder, that is pi r square is 1 square into height is 3.5. So the value of h we get, it is 22 by 7 into 35 by 10 into 1 by 22 into 1 by 20. So this 22 and 22 gets cancelled. It is 7 5s are 35. So the answer we are left with, it is equal to 5 by 200, and that is equal to 2.5 by 100 meter, and this value is equal to, if we multiply this value with 100, so it is 2.5 by 100 into 100 centimeter. So this is equal to 2.5 centimeter. So we are saying the rainfall on the roof is 2.5 centimeter, up to the height of 2.5 centimeter. Now the next question we have is, water flows through a circular pipe whose internal diameter is 2 centimeter. It means radius of this pipe, it is 1 centimeter, and water is flowing from this pipe into a cylindrical tank. There is a tank over here whose base radius, it is 40 centimeter. The rate at which, the speed at which the water is flowing, it is 0.7 meter per second, and it takes half an hour to fill this. By how much will the level of water rise in the tank in half an hour? Suppose we are saying at any instant of time, when we are talking about t is equal to 0, when the time t is equal to 0, this tank is completely empty. The water is there in this pipe up to this point over here. We start our clock, and the water has started flowing in this tank. So at the time t is equal to 30 minutes, the water, suppose, which was present at this point, when t is equal to 0, the water which was present at this point, it will reach up to this point. So how much distance this water has traveled, that is given by 0.7 into 60 into 30. We are saying into 60 means this is in 1 minute and this is in 30 minutes. So this much meter of distance the water has traveled. So it means we are interested in the amount of water present in this pipe. We are talking about the amount of water present in this pipe when the value of h is equal to this and r is equal to 1 centimeter. So the volume we have, that is equal to pi into r square into h. The value of h we have 0.7 into 60 into 30, this much meters. Now we are saying that this is by 100 square. So this volume, this should be equal to, suppose the level of water that is raised over here, it is say capital H. So this volume should be equal to the volume of the cylinder up to the height h, and that value is pi. The radius we have, it is 40 by 100 square. We are taking all the values in meters into h. So the value of h that we will get, this pi and pi gets cancelled, this upon 100 and upon 100 gets cancelled. So the value of h we have, it is equal to 0.7 into 60 into 30 over 40 into 40. So these two zeros gets cancelled, and the answer we are left with is, this is 2 over here. So when we multiply these terms, it is 0.7 into 9 over 8, and this answer comes out to be 6.3 over 8, and that is equal to 0.7875 meter. And when we convert this value to centimeter, we get the answer is 78.75 centimeters. So we are saying the rise in level is 78.75 centimeters. Now the next question we have, water is flowing at the rate of 15 km per hour through a pipe whose diameter is 14 centimeter. It means radius of this pipe, this is given 7 centimeter, and the water flowing through this pipe, it is falling in a tank. A tank is there. Suppose we are talking about, this is the tank we have over here, and this water is flowing in this tank. The original quantity of water in this tank, say it is up to this point, and we are saying that the water is flowing at 15 km per hour. The speed with which water is flowing, it is 15 km per hour. The diameter is given this, and the block that is given over here, the length we have over here, it is 50 meter, this tank we are talking about, and the width of this tank we have, it is 44 meter, and we want to find the time in which the level of the water will rise by 21 centimeter. So we are saying original level is this, the level should increase by the quantity, the height over here, it should be 21 centimeter. It means the quantity of water we are talking about, this is the quantity of water we require to flow through this pipe. So the quantity of water we have, that is the volume of this region. So it is 50 into 44 into 21 by 100. We require this much meter cube of water to flow from this pipe. So we are saying when the time t is equal to 0, at time t is equal to 0, when this pipe is filled with water, we are saying we require this much meter cube of water. So suppose we are saying that this much meter cube of water, it is up to this length. We are saying it is up to this h height we are talking about, or this length we are talking about, that within this length the volume of water we have, it is equal to this. So we want to calculate this value of h. So the volume of water in this pipe up to this length h, it is pi r square, it is 7 by 100 square into h, that should be equal to this volume, that is the volume of water we require, 50 into 44 into 21 by 100. So from this we can calculate the value of h, and it comes out to be 50 into 44 into 21 by 100 into 100 by 7 into 100 by 7 into 7 by 22. This is the value of h that we have. So it means at the time t is equal to 0, if some particle of water we are talking about at this point, after it has to move this much distance, what we want to calculate in this question is, we have to find the time in which the level of water will rise by 21 centimeter. It means we want to calculate the time in which the position of this point of water, the particle, suppose I am talking about some drop of water at this point, it should have moved up to this, that is, it should have moved this much meters of distance. We require the time. Now it is given that the speed of the water is 15 km per hour, that is equal to 15000 meters per hour. It means this much distance it is traveling in 1 hour. We want to calculate this much distance it will travel in. We are saying 15,000 meters it is traveling in 1 hour. this is the distance, h distance it will travel in 1 by 15000 into 50 into 44 into 21 by 100 into 100 by 7 into 100 by 7 into 7 by 22 hours. So on solving this, we will get this 7 and this 7 gets cancelled. This 100 and 100 get cancelled. 2 zeros are cancelled over here. Now this 22 and 44 gets cancelled. 7 3s are 21 and this 3 5s are 15 and this 50 and 50 gets cancelled, and the answer we are left with is 2 hours. It means it will take 2 hours for this particle at the time t is equal to 0, the particle which is at this point, it will reach the end point over here in 2 hours, and this much volume of water, this region we are talking about, this volume of water, this is equal to this volume that will raise the height of the water in the tank by 21 centimeters. Now the next question we have is that a farmer connects a pipe of internal diameter 20 centimeter from a canal into a cylindrical tank in his field which is 10 meter in diameter and 2 meter deep. So he has a cylindrical tank and the dimensions of the tank they are given, that the radius of this tank is 5 meter and this tank is 2 meter deep, and a pipe he has connected from the canal to this tank, and the diameter of this pipe, it is given to be 10 centimeters. If water flows through the pipe at the rate of the speed at which the water flows through the pipe, it is given to be 3 km per hour. In how much time will the tank be filled? So again we are saying that how much water we require, it is the volume of this tank, and the volume of this tank, it is pi r square into h. So this is 50 times pi, this much meter cube. This is the volume of this tank, this is the amount of water we require. Now we are saying, suppose this much water, we are saying corresponding to this much volume, 50 pi volume, we are saying the radius is given to be 10 centimeter for this pipe. The corresponding height that we have, that how much length of pipe we require to store this much water, we are calculating. We are saying, suppose the value of h we have, it is, we can calculate using the formula that this is the value h. So the volume of this pipe, if the length of this pipe it is h, it is pi. We are talking about all the quantities in meters, so it is 10 by 100 square into h, that is equal to 50 pi. So pi gets cancelled and the value of h that we get, that is equal to 5000 meters. We are saying the length we require, it is 5000 meters, that is equal to 5 kilometer. We require the length of the pipe to be 5 kilometer. Now the speed of the water, it is given to be that in 1 hour, we are saying it is moving 3 kilometer of distance, that is 3 kilometer of distance it is moving in 1 hour. We want to calculate the 5 kilometer of distance it will travel in 5 by 3 hours. 5 by 3 hours, 3 hours means we can write it is equal to 1 whole 1 hour plus 2 by 3 hours. Why we are saying this? We are writing 5 by 3, that is equal to 1 whole 2 by 3. So what is this 2 by 3 hours? When we look at this value 2 by 3 hours, if we multiply it with 6g, the answer we are left with is 40 minutes. So the final answer we are getting, it is 1 hour and 40 minutes. We are saying the final answer we will get, it is 1 hour and 40 minutes. That is, this is the time required to fill this tank. Next we have is water is flowing at the rate of 2.52 km per hour through a cylindrical pipe into a cylindrical tank, the radius of whose base is 40 centimeters. We are saying a cylindrical pipe is there and the water is flowing through this pipe to another cylindrical tank whose base is given to be, whose radius is given to be 40 centimeter. The speed of the water is given to be 2.52 km per hour. If the increase in the level of water in the tank in half an hour, suppose we are saying the original level of water in the tank, it is this. The water has flown for half an hour. For half hour, it means how much distance we are talking about corresponding to this pipe. This distance we are talking about, it is 2.52 by 2 kilometer. This distance we are talking about, and this comes out to be 1260 meters. We are saying if it has taken half hour, and how much level of water has increased? We are saying the level of water that has increased over here, it is 3.15 meter. It means how much quantity of water is collected in this tank? It is pi into r square is 40 by 100 square into 3.15. This much meter cube of water we are talking about, it is collected in half an hour. Now what we have to do is we have to calculate the internal diameter of the pipe. Suppose we are saying the radius, the internal radius of this pipe, it is r. How much water we are talking over here? We are talking about the water in this region, the volume of the water in this region, that is equal to the volume of water in this region. Now the volume of water in this region over here, this is given by pi r square into height, it is 1260, that is the distance traveled by the water in half an hour, and this should be equal to pi into 40 by 100 square into 3.15. So this pi and pi gets cancelled. So the value of r square we have, it is 40 by 100 square into 3.15 by 1260. So if we remove this decimal from here, we will get it is, if we are removing this decimal from here, we are getting it is 1 by 100 over here. So we get r square is equal to this value we have, it is 4 by 10 square into 1 by 10 square into, when we divide these two values, we are saying it is 315 divided by 1260. The answer you will get, it is 0.025, and this 0.025 you can write it like 25 by 10 raised to the power 3. So the value of r that we will get, it is equal to it is 10 raised to the power 2, not 3, it is 10 raised to the power 2. So the value of r we get, it is 4 by 10 into 1 by 10 into 5 by 10. So the answer we get, it is 20 by 1000. It is this much meters. So if we convert it to centimeter, we are multiplying it with 100. So we are saying it is equal to 2 centimeters. So the radius of this pipe is equal to 2 centimeters. So the diameter of this pipe, the internal diameter of this pipe, that is equal to 4 centimeters. This is the internal diameter of this pipe. Next we have is a 21 meter deep well with diameter 6 meter. We are saying a well is there and it is 21 meter deep and the diameter is 6 meter. It means the radius is equal to 3 meter. The earth from digging is evenly spread to form a platform. Whatever earth is taken out of this well, this whole earth, it is collected to form a platform. We are saying a platform is formed over here like this, and it is given that the dimensions of this platform, it is 27 into 11. This is the 27 is the width and length, and 11th meter is the width of this platform. This whole earth that is being dug out, it is spread over here. So we have to find the height of the platform. Suppose the height of this platform, it is h. So what we are saying, that the volume of the mud taken from this cylindrical tank, that should be equal to the volume of this cuboid that is formed. So the volume of this cylindrical tank, it is pi r square into h, and volume of this cuboid, we are saying it is 11 into 27 into h. So the value of h we have, it is 22 by 7 into 9 into 21 by 11 into 27. So these two gets cancelled. We are left with this 2. This 7 and 21, these gets cancelled, and this 9 3s are 27 gets cancelled. So we are left with this, the value of h we get, it is 2 meters. So we are saying the height of the platform that we will have, it is equal to 2 meters. Now next we have a well of diameter 4 meter is dug 14 meter deep. So we are talking about a well, and it is given that the diameter of this well, it is 4 meter. It means radius is equal to 2 meter, and it is dug 14 meter deep. The earth taken out of it is spread evenly around the well to form a 40 centimeter high embankment. The earth that is taken out of this well, it is spread around this well, and the height of this embankment, we are saying, this height we are talking about, it is 40 centimeter, that is equal to 40 by 100 meter. Find the width of the embankment. So we have to calculate the width of the embankment. So if we talk about this top portion, so we are saying this is the well, and the embankment around it, it is in this form. So we have a cylinder over here in this form. It is the inner portion, this is the outer portion. So we are saying the earth taken out of this well, the volume of the earth taken out of this well, that volume is, suppose the radius we are saying it is small r, the inner radius over here, this is small r, and the outer radius, it is capital R. The height over here, say it is capital H, and the height over here, this is small h. So the volume of the earth taken out, it is pi r square h, and it is spread in this region. We are talking about this earth taken out, it is spread in this region. So the volume of this portion, we are saying it is pi into the inner region we are talking about, it is basically pi into h, and it is capital R square minus small r square, and both these values should be equal. So if we substitute the values in this formula, we will see that this pi and pi gets cancelled. The height over here, it is capital H. So the value of capital H we want to calculate. It is the value of this capital H, it is given to be 40 by 100 into the value of capital R we do not know. The value of small r we have, it is 2 square, that is equal to 2 square into the value of small h we have, it is 40. So we get r square minus 4, that is equal to 4 into 14 into 5 by 2. So these two values get cancelled, it is 2 into this, so it is 140. So the value of r square we have, it is 144. The value of r we will get, that is equal to 12. We are saying value of r that we will have, it is equal to 12. That is the outer radius we are talking about. Why it is 12? Because it is radius, so we are taking only the positive value. Otherwise we are writing r is equal to plus minus 12, but we are neglecting this negative value because r is the radius. So we are saying this radius of this outer circle, it is 12 meters. So what we have to calculate is, we have to calculate the width of the embankment. So the width we have, we are saying the inner radius, it is 2. The outer radius we are talking about, it is 12. So the width that we will have over here, that is equal to 12 minus 2, that is equal to 10 meters. So this is the required width. Next we are given that a solid metallic cylinder is there, and metal was scooped out in hemispherical form of same diameter. The height of the cylinder is given to be, the height of this cylinder, it is given to be 10 centimeter, and its base radius is given to be 4.2 centimeter. So this portion it is 4.2 and this portion it is 4.2 centimeter. The rest of the cylinder is melted. So first of all we are talking about the volume of this cylinder, the remaining portion over here. So the volume of this whole cylinder, it is pi r square into h. This is the volume of the complete cylinder, and we have subtracted from it the volume of the two hemispheres. So volume of two hemisphere means it is equal to volume of the hemisphere. So it is 4 by 3 pi into r cube. This is the volume of this remaining cylinder. Now it is given that this, whatever the portion of cylinder is remaining, it is melted and a cylindrical wire is formed. A cylindrical wire is formed, and the thickness of this wire, it is 1.4 centimeter. It means the radius of this wire, it is given to be 0.7 centimeter. We have to find the length of this wire. Say the length, it is h. So the volume of this wire we have, it is pi r square means 0.7 square into h. We are saying whatever the volume of this wire is, that should be equal to the volume of the remaining material of this cylinder. So if we equate both these values, we will get, if we take pi common, 4.2 square common, what we are left with is 10 minus 4 by 3 into 4.2. This is equal to pi into 7 by 10 into 7 by 10 into h. So first of all this pi gets cancelled, and this 3 and 42 gets cancelled, and we are left with is 1.4. Now we are writing it is 42 by 10 into 42 by 10 into 10 minus 5.6. This is equal to 7 by 10 into 7 by 10 into h. So this 10 and 10 gets cancelled over here. This 7 and 7 gets cancelled over here. And when we subtract these values, you will get the answer. It is 6 into 6 into 4.4, that is equal to h. And this value comes out to be 158.4 centimeters, and this is the required length of this wire. This is the required length of this wire, that is equal to 158.4 centimeters. Now next we have is 50 circular plates, each of radius 7 centimeter. The radius is given 7 centimeter, and how many plates are there? We are saying there are total 50 such plates over there, like this. There are 50 such plates, and the thickness of each plate, this is the thickness we are talking about. The thickness of each plate we have, it is 5 mm. 5 mm means it is 5 by 10 centimeters. So how many plates are there? There are total 50 plates. It means this total length we have, that is equal to 5 by 10 into 50, that is equal to 25 centimeter. When they are kept one on another, it will form a cylinder. It will form a complete cylinder like this. The radius of this cylinder, it is 7 centimeter, and the height of this cylinder, it is 25 centimeter. We have to calculate the total surface area, and the formula for total surface area, we know it is 2 pi r into h plus r. So it is 2 into 22 by 7 into radius we have 7, h we have 25 and the radius we have it equal to 7. This 7 and 7 gets cancelled, so we are left with this 2 into 22 into 32 and the answer comes out to be 1408 centimeter square. So this is the area, surface area, the total surface area of the cylinder formed by superimposing all these, by keeping all these plates one on the other. Next we have is a copper wire 3 mm in diameter is wound about a cylinder whose length is 12 centimeter. We are saying we have a cylinder and the length of this cylinder, it is given to be 12 centimeter and the diameter of this cylinder is 10 centimeter. It means radius we have it is 5 centimeter. We are saying we have a copper wire and we have rotated that copper wire around this cylinder. Suppose the copper wire, we are saying it is in this form, it is rotated around this cylinder. This wire, when we are saying it is wire in this form and the diameter of this wire, it is the diameter of this wire, it is given to be 3 mm. So the radius of this wire, it is 1.5 mm, that is equal to 15 by 100 centimeter. This is the radius of this wire. We have to find the length and mass of the wire, assuming the density of copper is 8.8 grams per centimeter cube. So suppose we are saying the length of this wire that is required over here, that is equal to h. So it means when we are saying that, suppose I am again considering a small portion of this cylinder, I am saying if we have given one rotation to this wire, then next we have given another rotation to this wire. So what we are trying to do is, this is the width of this wire. The width of this wire, we are saying it is 3 mm, that is equal to 3 by 10 centimeter. So how much portion of the cylinder it has covered? It is 3 centimeter. It is 3 by 10 centimeter. Next again it has covered 3 by 10 centimeter. In the next round it has again covered 3 by 10 centimeter. What is the total length of this cylinder? It is 12 centimeters. So how many rounds of wire we require? It is number of turns that wire has to take to cover this complete cylinder, that is 12 over 3 into 10, that is equal to 40 turns. That is 40 times we have to rotate this wire, or we have to move this wire around this cylinder. Now when we are talking about the one round it will take, that will be equal to the circumference, the length of one round. We are saying length of wire for one round around this cylinder, we have, it is equal to the circumference of cylinder, and the circumference of this cylinder, that is equal to 2 pi r, and the value we will get, it is equal to 2 into 3.14 into radius of this cylinder, it is 5. So the answer we will get, it is 31.4 centimeters. So the total length of the wire, this is for the one round, so the total length of the wire will be 31.4 centimeter. And how many turns it has to take? It has to take 40 turns. So the total length of the wire we will have, it is equal to 1256 centimeter. So we are saying that the length of 40 turns will be equal to this much. The next thing we are saying is, this is the total length of the wire, the value of h that we have now, it is 1256 centimeter. So we are calculating next the volume of this wire. The radius of this wire is 15 by 100 centimeter. The length of this wire, it is 1256 centimeter. So the volume of this wire, that is pi r square L. The length we are saying, or we are writing pi r square h. So it is 3.14 into 0.15 into 0.15 into 1256. And on multiplying all these terms, the answer that we will get it is 88.74 centimeter cube. On multiplying these terms, the final answer we will get it is 88.74 centimeter cube. So it means this is the volume of the copper we require. Next, it is given that the density is 8.8 gram per centimeter cube. It means for 1 centimeter cube, the weight is 8.88 gram. How much quantity we have? It is 88.74 centimeter cube. So the weight will be 8.88 into 88.74, and the answer comes out to be 788.01, and that is equal to 788 grams approximately. So we are saying that we require 788 grams of copper. Now the next question we have is a cistern internally measuring. These are the dimensions of the cistern given to us, and it contains 129600 centimeter cube of water. Then it is given that porous bricks are placed in the water until the cistern is full to the brim. Each brick absorbs, it is given that each brick absorbs 1/17 of its own volume of water. How many bricks can be put in it without overflowing the water, and the dimensions of the brick they are given to us. So first of all, we are calculating the volume of the cistern. So the dimensions are given. These are the dimensions given. So the volume we calculate by multiplying all these terms, and the answer we obtain, it is 1980000 centimeter cube. Second thing that is given to us is that this much amount of water is already present in the cistern. So the empty space we have now, the empty space we have, it is 19800 minus 129600, and the answer we obtain, that is equal to 1850400 centimeter cube. So this is the empty space in the cistern. The next thing that we have is that the dimension of each brick is given to us. So corresponding to this dimension, the volume of each brick will be multiplication of all these terms. These are cuboidal bricks, so it is length into breadth into height, and by multiplying these terms, the answer we will obtain, it is 1096.875 centimeter cube. Next, it is given to us that each brick absorbs 1/17 of its own volume of water. This is the actual volume of the brick. It absorbs 1/17 part of the water. So effective volume we are talking about, it is the effective volume of each brick. We are saying, what this thing means is, we are saying suppose water is there. When we put a brick in this water, actually what should have happened, that whatever the volume of this brick is, same volume of water should come out. But it is given that the brick absorbs 1/17 portion of the water. It absorbs, it is V/17th portion it absorbs. So what is the effective volume of this brick? It is 16/17 times V. That is, when we put this brick in this water, the water that will be displaced, the volume of the water, suppose this tank is completely filled with water, we expect that the volume of water that should come out, it is capital V. But we are saying that it absorbs 1/17th part. So how much water effectively will come out? It is 16V/17. So we are saying this is the effective volume of each brick. So we are saying the effective volume of each brick, when we calculate, it is 16/17 times the actual volume of the brick. Now we have two things. One is, this is the empty space we have. 1850400, and this is the effective volume of the brick. So how many bricks can be there? The formula we have, it is volume of the empty space divided by the effective volume of the brick. So when we multiply these values, it is 1850400, and we are dividing it with 16 by 17 into 1096.875, and the answer on dividing these values, the approximate answer we will get, it is 1792. So these are the approximate number of bricks that can be put in the cistern without overflowing the water. Next we have is a right triangle whose sides are 3 centimeter and 4 centimeter other than the hypotenuse. So these are the two sides. So the value of the hypotenuse we will have, it is square root of 3 square plus 4 square, that is equal to square root of 9 plus 16. The answer we will get, it is 5 centimeter, is made to revolve about its hypotenuse. So it is shown in this figure that this AO and OB, these are the lengths we are saying. This is 3 centimeter, this length we are saying it is 4 centimeter, and this length we are saying it is 5 centimeter. This is right angled at O, and we have rotated this right angled triangle about the hypotenuse. It means we have kept this hypotenuse as fixed, this hypotenuse we have fixed, and we have rotated this point O. Then we have to find the volume and the surface area of the double cone so formed. So why we are saying it is double cone? Double cone means this is the one cone on this side and there is another cone on this side. We have to find the volume and the surface area of the double cone. So if we look at this cone over here, we are saying the total length we have, this total length we have, it is 5 centimeter, and this height we are talking about, this length it is 4 centimeter, this length it is 3 centimeter. Now first thing we have to calculate, it is the value of this length OP. We are talking about this length OP we want to calculate. So to calculate this length, we are talking about this right angled triangle, and we are saying we have joined, this is the point O, P, A and B. This angle over here it is 90 degree and this angle over here it is 90 degree. So if we calculate the area of the triangle A, we are talking about the area of the triangle AOB. The formula we have, it is half base is OA and height it is OB, and this value is equal to half base we are considering it is AB and height we have corresponding to AB, it is OP. So half and half gets cancelled. If we substitute the values over here, the value of AO we have, it is 3, the value of OB we have, it is 4, and the value of AB we have, it is 5. So the value of OP we have, that is equal to 3 into 4 by 5, and the answer comes out to be 2.4 centimeters. So we are saying this length OP we have, this is 2.4 centimeter. This length we are saying it is 2.4 centimeter. Now if we look at this right angle triangle over here, we are talking about this right angle triangle. This side we have, it is 2.4 centimeter, this side we have, it is 3 centimeter. So the value of this will be square root of 3 square minus 2.4 square. On solving this value, we will get it is equal to square root of 9 minus 5.76. And on solving this value, we have shown this calculation over it is 9 minus square root of 5 minus 76. The answer comes out to be square root of 3.24, and that is equal to 1.8 centimeters. So we move on to our next slide. So what we obtain from this is, we are saying we have a cone over here in this form, we have another cone over here, the sides of the radius of both these cones, that is equal to 2.4. This length we are saying it is 2.4 centimeter. The radius of this the slant height of this upper cone, it is 3 centimeter. The slant height of the lower cone, it is 4 centimeter. The height of this upper cone we have calculated, and it comes out to be 1.8 centimeter. The total height we have, it is 5 centimeter, that we have already calculated. So the height of this lower cone, we are talking about, it is 5 minus 1.8, and the answer comes out to be 3.2 centimeters. Now we have to calculate the volume and the surface area of the double cone. So the volume of the upper cone, that will be 1 by 3 pi. The radius we have, it is 2.4 square, and the height we have, it is 1.8. And the volume of the lower cone, it is 1 by 3 pi. Radius we have, it is 2.4 square, and the height we have, it is 3.2. So if we take 1 by 3 into 3.14 into 2.4 common, 2.4 square common, so we are left with this 1.8 plus 3.2, and this value comes out to be 5. On multiplying all these values, we will get the answer is 3.144 centimeter cube. These calculations, these are also shown over here. So this is the total volume of both these cones. The second thing we have to calculate, it is the total surface area. The formula for the curved surface area, the total surface area means we have to calculate the curved surface area of this upper cone. The curved surface area, it is pi r L1. L1 means this is the slant height we are talking about, plus the slant height of the second, it is pi r L2. So the answer we have, it is 3.14 into 3.14 into radius we have, it is 2.4, and L1 plus L2 means we are talking about 3 plus 4. So 3 plus 4 we get, it is equal to 7. So we have 7 over here. So in place of 3.14 we are using, it is 22 by 7. So this 7 and 7 get cancelled, and we are left with this 22 into 2.4, and answer comes out to be 52.8 centimeter square. So we are saying that this is the total surface area of this figure. It is sum of basically the curved surface area or lateral surface area of these two cones, but it is the total outer surface area of this double